In the previous lesson on semantic memory, we considered how two episodic memories of Tiger 1 and Tiger 2 might be transformed into a more schematized memory of a tiger at a zoo. And we said that the two episodic memories might have non-overlapping memory traces in the hippocampus, but up in the cortex, there might be overlapping activity between those two events. After all, there are similarities between Tiger 1 and Tiger 2. And it's these overlapping features in the cortical representation that come to be the schematized memory. So later on, after consolidation, that would be what is retrieved if somebody were remembering a tiger at a zoo. But they would have lost specific details of each episode if they're not reactivating the hippocampal portion of that episode. In this lesson, then, we'll take it a step further. How is it that we might begin to form categories? So while you can see Tiger 1, Tiger 2, Tiger 3 and form the concept of a tiger, what about when you look at a cheetah and a jaguar and form the concept of big cats? So let's begin then with what might be happening when we see the cheetah. Well, same story as with the tiger. The hippocampus is going to make a memory trace of the cheetah episode, and then consolidation will occur such that that cheetah episodic memory will be strengthened in the cortical systems. Now, if we think about then these two episodes, the tiger episode was last week, the cheetah episode was yesterday. We've got two separate episodic memories, and now we'll see if we can figure out what might be happening in the cortex to form the concept of big cats. Well, in this picture down here, we've got the red cortical cells and the blue cortical cells. So last week, when we saw the tiger at the zoo, we had the red cortical cells activated, forming part of the cortical memory for the tiger at the zoo. But yesterday, we saw the cheetah, and that activated the blue cells in the cortex, making a cheetah representation. However, some of the cells of the cheetah representation were also activated last week when we saw the tiger. So here we have the overlapping pattern of activation. And this may be the way that the brain represents the common features of a tiger and a cheetah, thus helping us form the concept of big cats. Well, now, why would there be overlapping neural activity? Because tigers and cheetahs have similar characteristics. They have 4 legs, and they have teeth and tails and fur, etc., and they chase things and eat them. And researchers also suspect that the consolidation process itself enhances the common elements at the expense of outliers, and this allows for the formation of semantic categories. So maybe consolidation is helping the semantic memory system find these commonalities. And when you find the commonalities between tigers and cheetahs, it allows you to set up new categories like big cats. So back to our little diagram like this, we know that birds are animals. So animal is the larger category, and bird is a member of that category. Well, how is it that we formed the animal category? Well, because we had a lot of different examples in birds and mammals and reptiles and such, and they have similar characteristics. And whatever those similar characteristics are, that's the basics of what it is to be an animal, right? So again, the idea is that what the brain can do when there are overlapping patterns of neural activity, those connections can be strengthened in a way such that the overlapping pattern comes to represent a larger categorical idea, in this case, big cats for the tiger and cheetah, or animal for all the different types of animals that we might have learned about.